Hi, and welcome to my video showing you how to do reacting mass calculations. This topic comes up in GCSE science and it can be quite a difficult topic to do, but if you follow my method, I'm going to go through some worked examples with you. It's a simple 3-step question and hopefully you will find them easier to do. It is also covered in A-level chemistry, but obviously at A-level chemistry it does get a bit more complicated. So here is a question which I've taken just from an exam paper, and it's asking you to work out reacting masses. So here's the equation first of all. Okay, and I'm just writing it in. And what I need to check first if it's balanced, and it has been balanced. If it hasn't, they would normally ask you to do that first. And to do these sort of questions, you only need to know one formula. So before doing this question, you need to know how to work out the number of moles. And you also need to know how to rearrange it. So the formula is moles equals mass in grams, usually divided by the relative formula mass or relative atomic mass or the molecular weight. There's lots of names. And I've written here periodic table because you get the information from the periodic table. And I always like to do these triangles just in case you're not very confident with rearranging them. So mass goes at the top, moles in one corner, relative formula mass in another, and then you put your divide and your times. Okay, step 1 in all of these calculations is to work out the number of moles. Step 2 is to look at the ratios, and I will explain that in a bit more detail. And step 3 is to work out your answer by rearranging the equation. And the equation I'm talking about is the equation given there for moles. So if we start off by underlining the information they've given us, they give us 1 gram of magnesium, and they want us to work out how much magnesium oxide we're going to make. They want us to work out the mass, so it's in grams. That's your first step, and then I always connect them, and you'll see why. Okay, the first step is to work out the moles. I can only work out the moles of magnesium because they give me the amount of magnesium. So moles equals mass over RFM. They give me 1 gram, and magnesium is from the periodic table, but in this question they give it to you, 1 over 24. And if I do a quick calculation on that, it comes up to 0.0417. So I've just rounded it off. Okay, step 2 is to look at your ratios, and this is why I did the connecting line. Because if you look at the equation, there is 1 mole of magnesium reacting with 1 mole of magnesium oxide. There's an invisible 1 before those. I don't have 1 mole, I have 0.0417, which means I have 0.0417 moles of magnesium oxide. And finally, I've just corrected a mistake that I realized there. We're going to work out the mass by rearranging that equation. If you look at this, the mass equals moles times RFM. How do I get RFM? But this time it's the RFM of what I'm trying to work out. Look at where I put the question mark at the top. It's magnesium oxide this time. So that is magnesium oxide is magnesium plus 1 oxygen in the formula. That comes up to 40. And when you multiply the two numbers, you get 1.67 grams. So that is the way to work out these questions. Step 1, step 2, and step 3. If you want to, you can rewind the video to the beginning of this question and try it out yourself. The most common step that students struggle with is step 2 because of the ratios. To be honest, in GCSE the ratio will always be 1, so you can skip that step, but I wouldn't recommend it. When the ratio is 1 to 2 or 2 to 1 or 2 to 3, that normally comes up in A-level. Okay, a second question. Again, this has been taken from a real exam paper, and this was a 3-mark question. So we're reacting copper carbonate. Oh, I think I'm doing something else. There wasn't enough space there. So what I'm going to do is when I can figure out how to use this, I'm just going to make a little bit more space there because I have big writing. So copper carbonate reacts with hydrochloric acid, and you make copper chloride plus carbon dioxide plus water. So as before, I'm going to write down the information they've given me in the question. So it says, calculate the mass of copper carbonate. So I need to put a question mark underneath copper carbonate, because that's what I'm trying to work out. They want me to work out the mass, so it has to be in grams. I'm ticking it off. And they give me hydrochloric acid, and then I start off with 11 grams of copper chloride. And then what I should do is connect those two, and you'll see why in a minute. Again, I'm going to write the formula, moles equals mass over RFM, or RAM, or MR, lots of different versions. I'm going to make my triangle. Okay. And then step 1. And if you remember, it was to work out the moles. The moles of what? Well, look at the information they've given. They've given me information about copper chloride, CuCl2, 11 grams. So that's what I'm going to work out the moles of. CuCl2 equals mass over RFM. The mass is 11. And from the periodic table, actually I didn't need to look at the periodic table because they actually give you the numbers that you need in the question. So copper is 63.5, but there are 2 chlorines, so I do 35.5 times 2. And what I'm doing now is I'm just adding up the bottom numbers in the brackets. And that comes up to 11 over 134.5. And then when you work that out, it comes up to 0.082. I've rounded that off again. Okay, step 1. Step 2, if you remember this, is the ratio. And the ratio of what? Look at the 2 things that I've connected in my question. So I'm going to write those 2 things down like this. Okay, with the numbers that are in front. Now, because if there is no number in front of it in the equation, you just write a 1. I don't have 1 mole of copper carbonate, so I have 0.082 of copper chloride. I assume I have the same number of moles because it's a 1-to-1 ratio. Step 3 is to work out the mass by rearranging the equation. Why do I want to work out mass? Because I put a big question mark there. Copper carbonate in grams, I'm working out the mass. And I'm running out of space, so I'm just going to write it here. Mass equals moles times relative formula mass. So it's going to be 0.082 times copper, which is 63.5. Because copper carbonate has got copper in it. It has a carbon, which is 12. And it has 3 oxygens, so I'm going to do 16 times 3. So that makes, I'm just adding up the brackets here again, 123.5, and if you multiply them together, we get 10.127 grams. And that's your answer. Step 1, step 2, step 3. Okay. Moving on to question number 3. And if you look at this question, I'm just going to make space so that I can type in. I can write the question. So this time we're reacting iron with chlorine to make iron 3 chloride. This equation is given to you in the question actually, and I'm just balancing it, and it was already balanced. So, as before, calculate the mass of iron 3 chloride. So I'm working out the mass, so I put a question mark under iron 3 chloride. And I put 11.2 underneath iron, and I should have connected them, but guess what, I forgot. So you should really do an arrow connecting the 2 things. And then just to remind myself, I'm writing the formula again. And I'm writing the triangle, so that I don't make any mistakes when I'm working out step 3. Okay, number 1, what do I do? You work out the number of moles of Fe, because that's the only thing I know. I only know the mass of Fe. There's my formula. The mass is 11.20 grams, and Fe is given to me. It's 56. And when you work that out, I have to double check it. That's 0.2. Number 2 is look at the ratios. The ratios of what? Well, the two things that have got things written down in them in the question. So the FeCl3. There you go. Now I've done my connecting arrow. So it's the number before the Fe is a 2 and the number before the Cl3 is a 2, but that is just like a 1-to-1 ratio. So I have 0.2 and 0.2. I'm taking my answer from part 1. And then the last part is to rearrange the equation to work out mass. How do I know I'm working out mass? Because look, grams, question mark. FeCl3 this time. So use the triangle. Mass equals moles times RFM. What is the moles? The answer from number 2, from part 2, 0.2. The relative formula mass, iron is 56 and 3 chlorines. So I'm going to do 35.5 times 3. I'm going to add up the brackets. What's inside the bracket? And that 162.5. Multiply the two numbers together and I get 35.2 grams. And as I'm doing these questions are getting quicker and quicker. Okay, so this is taken from, the previous 3 questions were from AQA. This is from Edexcel. What's different about Edexcel? They've actually been kinder to you. They've actually worked out the relative formula masses for you. The relative formula masses have been given to you, which is nice because it means less calculations and less chance of you making a mistake. So as before, we're trying to work out this time sodium carbonate in grams because they want the answer in grams. Oh, no, it's not grams. If you look at the number they've given you kilograms. So I want the answer in kilograms. So you don't need to convert it to grams. And I start off with 40 kilograms of calcium carbonate and I do my connecting arrow. And again, as before, I'm going to write my formula for working out moles. And then I'm going to do my triangle like before. And change the color and put divide in between the top and the bottoms and multiplying in between the bottom 2 corners. And number 1, what do I do for step 1? I'm rubbing that out. I'm just going to write 1. Work out moles. Work out moles of what? Well, I can't work out moles of Na2CO3 because there's a question mark under it. But I can work out moles of calcium carbonate because they tell me I've got 40 kilograms. So CaCO3, moles of CaCO3 equals mass over the MR. I've said MR, I also mean relative formula mass. I'm going to change it. There you go, in case you get confused. This thing has lots of different names depending on what you're talking about. The mass is 40. The relative formula mass of calcium carbonate, I don't need to work it out because they give it to me. It's 100. So that makes 0.4. Okay, do you remember what step 2 was? Ratios. And the ratios of what? Look at the two things that are connected. Write those two things down again, but this time put a ratio sign. If there is a number in front of calcium carbonate, put it, and the same for sodium carbonate, but there isn't, which means that the ratio is 1-to-1. So you write a 1-to-1. Now I take my answer from part 1, okay, because I don't have 1 mole, I have 0.4 moles, so I'm going to write 0.4. That looks really messy, so you'll see what happens in a minute. Okay, I'm going to rub out the arrow. There we go. So 0.4, it's a 1-to-1 ratio. So if I have 0.4 from part 1, it means I also have 0.4 for part 2. And then you rearrange your mole equation. You can use your triangle if you want to work out the mass. And the mass of what? This is really important. It's the mass, this time, of Na2CO3. and they give you the relative formula mass of it as well. So let's rearrange the equation, and using the triangle, mass equals moles times relative formula mass. The moles is taken from part 2, 0.4. And the relative formula mass, they give it to you in the question. Relative formula mass is 106. And we do our multiplication. And that comes up to 42.4 kilograms, not grams this time. And that is as difficult as they get. This question involves using mole and this formula. There will be more videos showing different types of reacting mass calculations involving titrations and gases as well. But this is the simplest type of mole calculation and reacting mass calculation that you can do. Thank you for listening. I hope you've enjoyed watching my video. Do give it a thumbs up, and if you have any questions or you want to make a comment, please subscribe and make a comment down below.